I joined Netflix about a year and a half ago, and in the period, I was excited to work on some really interesting projects already. Some of the projects I worked on include packages lifecycle simplification, SAP data model refactor, microservice event sourcing framework, end-to-end automated test framework, SAP Test API, and more recently, the group key and the single package model as it relates to additional original languages initiative. I've been working closely with Mark. All of these projects are very collaborative in nature, and I'm really, really thrilled to be working in a team with so many talented engineers and leaders. Super brief history. I came from Hulu, where I was a principal engineer in their equivalent of MCE, which is like the ingest pipeline for their live video streaming. And prior to Hulu, I was at Oracle working on Oracle Cloud Services. So I'm going to move on to, for today's sharing session, I wanted to talk about something I'm very passionate about, which is code quality and ways in which we can improve our tests so that we can increase the confidence of our team to make changes, also to lower the costs associated with testing and maintenance. So today I'll talk about the problem of API level testing, and one way in which it can be achieved through existing technologies like Spring Cloud Contracts. I'll also show how SAP has leveraged the Spring Cloud Contracts and integrated it in our continuous integration flow. And at the end of the talk, I really hope you will know something about contract-based testing and how SAP has used it to implement API level test automation. I will talk about the differences between some various types of tests and why it is important to include API level tests in your CI process. I'll also show you why relying on mocks alone in integration tests can have some pretty detrimental outcomes. And I will do some examples. So here's what we call the testing pyramid. How many people have seen this before? You can raise your hand if you've seen this kind of depiction of tests. Yep. Yeah, this is pretty standard stuff. Well, how many of you think this is maybe not the best way to distribute tests? Well, okay. Well, it turns out not everyone agrees exactly on what the right amount of different test types should be, and I don't really plan to discuss that since different teams have different requirements. But generally speaking, this pyramid represents the kind of like the most common distribution you'll find across different companies, right? See, at the very bottom we have unit tests, and the fact that it occupies the largest area, it implies that most of our tests should be unit tests. Unit tests are considered cheap and can be very effective at ensuring code coverage and low bug count. Next up, we have integration tests, which are our service and API tests. As it turns out, these tests are not easy to do right, and their usefulness vary depending on the methodologies we use and how rigorous we are about really following TDD or behavior-driven type of tests. But they can be fairly difficult to get right. Contract testing, actually, what is the topic of today's discussion, is something that targets these level of testing, and it should make them a lot more accurate. And that's something that we'll try to show you today. Higher up as we go, we have end-to-end tests, and finally at the top we have manual tests. So which of these tests do you guys think that are slowest and which are the fastest? This, right? Okay, everybody knows that. Like, you write a unit test, boom, it's very fast, it's very cheap to do. Similar, so related to this, as we go up the pyramid, we notice that the isolation of the tests and the modules becomes the tests become less isolated, right? So at the unit level, we have the most isolation, and then the complexity kind of grows as we go up the pyramid, and things get there are too many variables being added, and and also the cost increases. One thing to note about the cost is it's not just the effort that we're putting into writing this test, right? I mean, it can take you 5 minutes to write a contract service API test, but it's finding issues higher up in the hierarchy that really costs the most. Clearly, at the very top, you have production, where once you find issues there, it can be very costly. Data could get corrupted. We may have to do, depending on the what might have gotten deleted or whatnot, the ramifications of that are different. But cost definitely increases as we go up the pyramid. So let's discuss the unit test really quick. This is not a tutorial on unit tests. Of course, everyone's using unit tests, but just for the sake of the conversation, it's worth mentioning that they're very important as they test individual units of source code. This is absolutely required to ensure the correct functioning of the code we write. And they're fast. We can test components in isolation. Units can be, method, class, module, set of modules, etc. So one thing we all kind of try to do with unit tests is not to test the implementation, right? We focus on the actual on the use case, on the behavior. And one simple example is if we were to switch our underlying persistent store from something like from MySQL to Postgres, we should not have to change many unit tests, right? Ideally, if we've done the right thing. So really should not be testing the implementation, should be testing the behavior. And one thing to note about the unit tests is they're really ideal for this TDD style of development, right? We typically explore the use cases, we talk to product managers, we explore the market, we figure out what is it we're building, and then we translate those things into a very specific and concrete use cases, and those use cases really translate into tests, right? And so if you're a purist in the TDD world, you'll say, I'm not going to write a single line of code until I have my test written, right? That can be a bit extreme, but some people prefer that, which is fine. But the idea of TDD, in my opinion, really is to kind of think of testing and writing code as like one single thing, right? You write some tests, you write a little bit of code, you go refactor, and you kind of go back and forth until you kind of get it right. It's clearly most of our tests are unit tests, and I think that's a good thing. Service integration tests include checking our services and APIs, right? As I mentioned, as the isolation of the test decreases, which is as we're moving up the testing pyramid, the complexity of the business logic and dependence on other components increases. So this basically means it gets harder to write effective tests that check behavior in isolation. So just as unit tests can be misguided, it is easy to write generic integration tests that are wasteful and really do not add much benefit to the quality assurance. So as I will explain in a bit, concheck tests, again, address this problem, and they're supposed to kind of minimize this kind of wastefulness. And finally, end-to-end tests, they're slow and costly. They're even higher in the hierarchy of complexity, and the number of variables that can affect the result increases, right? So, the tests can be very slow and also costs us a lot of human effort if done manually. So when we do have E2E, we really should try to automate them as much as possible. SAP has actually invested into building, we have a dedicated E2E testing framework. We call it SAP Test API, and we managed to integrate it into our daily continuous integration flow, and really seeing some really good results with that. So let's talk about mocks now. So why is using mocks? What are some of the problems with using mocks for integration tests? Let's think of a case where we have written a test that mocks a response of a service, we run the test locally, it passes. That's great. How many people think that this is sufficient to ensure quality of our code? Like, does anyone think that we're good now? We got our mocks, our integration tests are passing, we're good to ship. All right, I don't see any hands, which is good. And why is that? Because it oftentimes doesn't work, right? So why is that? Well, I mean, the stubs we use, the payloads that we generate from using mocks for services we don't own are really not reflecting the reality, right? They're reflecting our idea of what the reality is, or maybe like reality at some snapshot in time, but they may not really match what the service is doing right now. And so we're really not testing the right thing. And so let's see how we can address this problem, right? So how can we improve this the sync between the actual consumer and producer? So before we get to contract testing and see how it solves the issue of mock testing, we need to define some terms. Let's call producer a service that exposes an API. This API could be consumed by some team or be external. We also say that if a service sends a message, it's really a producer of that message, right? And that a consumer is really a service that just depends on some API or some message, and it basically consumes an API or a message. And here's some examples within the CPP. We have some producers and consumers. Like CCM is a consumer of SAP packages. They call our API. SAP Backlot is a consumer of MCE Ingresso, and so on. And like down at the bottom, you can see also Oscar service is sending messages into a queue, which we are consuming, and therefore, in this case, SAP Backlot is acting as a consumer. And it's important to note that same actors here, Backlot, and can play different roles depending on the use case, right? It could be consumer, in some cases it can be a producer, right? So it's important to, when you think about the contract testing, to think in which role am I right now, like as a consumer or as a producer, right? And so that brings us to the actual contract. And what is a contract? Well, it's really an agreement between a producer and a consumer on how the API or a message should look like. It's important not to confuse this with an actual, with a schema, because contract is not about, it's not like an XML schema or JSON schema of every possible payload that this endpoint can produce, right? That's not what the contract is about. It's really behavior driven. It's like a team comes to you and says, I really need to create an asset, and I have this 3 fields, and what am I going to get back? And that becomes your contract. You say, okay, from now on, every time you give us these 3 fields, you're going to get this payload, and that's very use case driven type of contract that you create, and that actually translates right into this definition I'll talk about in a little bit. There are different types of contract testings. There is a provider. There's a provider, which is really a producer contract testing, consumer contract testing, and then consumer-driven contract testing, right? And so let's talk about provider really quick. This is a case where a producer kind of let's assume we have 2 consumers, consumer A and consumer B, and we have a service which is the producer of this API. And so when we're talking about provider contract testing, the service or the provider states how the API should look like. And the service interface is really defined for all consumers, regardless of how individual consumers may use the API. So if a consumer A only needs like the triangle, and the B needs a circle, well, they would still get all shapes. Shapes here do not necessarily mean like endpoints. They could be same endpoint, but perhaps different type of response, which had maybe like the shape of the payload, etc. Right? So it's important to think about this, not necessarily just like different endpoints, but maybe like a different behavior or response shape of the payload. So in this model, the implementer of a service really defines the interface of a service, and everyone uses the same interface. A consumer on the contract testing, on the other hand, is let's again assume two consumers, A and B. In this case, however, each consumer sends their requirements to the service implementer, and the service combines all shapes. So consumer A doesn't really care about consumer B and the star shape or whatever the payload, that part of the payload maybe, or some of the endpoints. And consumer B may only care about star, right? So at that point, it's up to the service to define contracts for consumer A and B, and in doing so, it comes up with like an all-inclusive type of interface that suits all these different consumers. So the difference between provider contract tests and consumer is really that, like with the provider testing, service exposes an API and says, hey, there is no other way to use it, while in consumer tests, like the consumer expresses how their API should look, and then the service implementer actually takes that into consideration. It is often the case that a service starts as a consumer type of provider contract testing model, and then as it scales up, it may not be able to cater to all the needs of different consumers. Think about AWS, for example. They just expose and they publish their API, and they're like, well, this is how it works. And I'm sure they have contracts that test those, like the provider level contracts, but they cannot cater to every different kind of user. In CPP, I believe that this is perfectly suited for the kind of collaborative environment we have between different teams where we can have a conversation and make sure that our service actually caters to the needs of the consumer. And so finally, we get to what we call consumer-driven contract testing, which is what we're primarily using in SAP, and what I think is a very effective way to have a quality API interoperability between teams. So in this case, we have a mix of two contract testing styles. The image you see below is from the Martin Fowler's blog, and it's been around for many years. As we're finding out, some of the best innovations are really kind of like repackaged old concepts. gRPC, anybody use Corba a long time ago? I mean, so we're kind of going back and forth, and that's great. Not quite the same, but we're always like improving on it, I believe. So in this case, we're kind of taking this concept that's been around for a while called consumer-driven contract testing. And in this image, we have basically a producer on the left side, and you see the consumers. And the key about this, more like a paradigm, there's like a conversation that's happening between consumers and producers. And this conversation is crucial. The provider can then turn these. So the key is consumer, and this conversation is the driver of that definition of that, the interface, the contract, right? And so consumers' expectations eventually turn into what we call a contract test. So I'm going to move on to talk a little bit about test-driven development. So as I explained, the TDD is a fairly popular way of development that ensures quality as you code it. We start with the failing test, and then we make it pass, and then we refactor the tests and until it kind of meets our expectations. We're constantly putting pressure on our code to make sure that it meets the design needs. And we can actually do the same thing with the contracts. An example of that would be we send requests to a non-existing API. This would fail, of course. And then we define contract of what we expect in the response. This should pass it, and then we refactor as just in TDD with the unit tests. So, and now this brings me to the technology that we've actually leveraged to accomplish these consumer-driven testing in SAP. And turns out Spring, as they have tons of really useful features in this in their Spring Cloud under that umbrella project. And one of them is actually this Spring Cloud Contracts, and they're actually giving you a lot of the tools out of the box, one single jar. You can add it to your build Gradle, and then you get this verifier that allows you to implement consumer-driven contracts. Contracts are written in YAML. You can also write them in Groovy. I prefer YAML myself because I think it's a kind of, I like the idea of data-driven and declarative way of specifying these contracts. And also they're kind of cross, you know, they don't depend on any particular technology, as opposed to if you use it Groovy, you would require Groovy and maybe Java. But the contracts can be used in fact, in non-Spring and non-JVM projects. So when we start, I'll go into definition really quick, and I'm going to do a little bit a short demo to show you how this works. But the contract definition generates a few things. It's like a Java. You write Java, you compile it, and you get the bytecode. With the Spring Cloud, you write this definition, which is in YAML, and then you get the stub definitions, and they can be used in mock servers to actually simulate responses. This is a really, really neat feature. We're not taking advantage of this quite yet, but I really look forward to doing more with this. Just to give you a quick example of how this can be used, we define a contract or what happens when you invoke an API in packages, for example. And that contract will actually produce what's called a stub. And that stub can then be used by any consumer like CCM or other teams to actually verify their business logic and their implementation without ever needing to ever make a connection to our server, right? So this is really, really neat way of allowing that integration to be a lot more streamlined and more accurate. Assuming that these stubs are generated every time they should be part of your continuous integration flow, where every time you build your project, your stubs get compiled, they get pushed to Git, or you know, it could be like just a repository, or even other places you can publish them. But the idea is that whenever you build a new version of your code base, these stubs are available for all the consumers to test their implementation against. Again, we're not using this really cool stuff though. Message stubs, similar to the stub definitions, they can, out of the contracts, you can create this fake messages. And then what we are using is this acceptance test and auto generation aspect of the Spring Cloud contracts. We define the contracts, and this just gives us tons of generated JUnit 5. In our case, you can choose POC, and they verify these API integrations every time we build our project. Really cool stuff. And I'm going to go into one example, and then I'm going to leave some time for questions. But any questions so far? Okay, take a sip. So the example I'm using is from one of our consumers, which is a CCM product. And they ingest a promotional asset into SAP. In this case, CCM is considered a consumer, packages is the producer, and the API contracts that we're considering in this case would be the create package, which they invoke, and then also create source request. So let's look at one of these contracts. CCM create package contract. Basically, this is what the layout of our module or our project looks like. You notice within the packages, the backend, we create a separate module to hold all of these contracts. And then, excuse me, this is the only Java code we have. I'll show you in a bit. It's very light. It's almost like codeless type of a solution, right? You don't have to code much. And then we create these subfolders to hold these consumer-driven contracts. And as you can see, we have two consumer-driven. We have Content Hub and CCM. And then we have a number of contracts that are simply, we consider them as kind of like a provider level, where we don't necessarily have a contract with the consumer, but we know that either our UI is using them or somebody else may use them, and we create contracts to make sure that they produce the expected outcomes, expected payloads and results. And so going back to that, if you remember seeing the consumer-driven or the consumer contract testing, where you saw different shapes, and different consumers may need different shapes in the API. This is one example of that, where CCM may only be interested in one particular invocation of our create package API, and they may be interested in maybe just getting certain kind of payload. That's what they want to verify, while maybe Content Hub may have a different requirement. So this is an example of that type of consumer contract testing, but consumer driven in the sense that, we talk to Yogita, we talk to the CCM team, and we ask them, what is it you need? And we derive these payloads. And so let's look at this Java class that we use as a base class for all of the contracts. This is part of the framework. The Spring Cloud contract framework allows you to define this base test class. So you define it in your build Radle. I'll show you in a sec. You just specify the set of controllers that will be part of your contract testing. So any API you plan to invoke that is served by these controllers, just put them here. You can literally copy and paste this and replace them with your controllers. This code really does not need to change across different teams, just modify it to have your set of controllers. And then here's a contract. So what do we have here? This is you can think of it as kind of like a unit test, where you're saying, this is the endpoint that's under test. I'm testing this API you want external package create. These are the headers I want to send it, and this is the payload I want to send it. And this is what I expect in response, and you define your expectations here. Now, this matchers body is optional, and you can do it without it. And at that point, you're simply saying, when I call this API, I want to do equality check, literally based on status and headers, and the payload that's coming back has got to be exactly the same. And here's an example of the request payload we have for this particular use case. We're creating a project, a package of type proxy. And this is the response that we expect back. And so this is literally, these payloads are literally taken out of Swagger. That's the beautiful thing about this solution, where you may find an issue and you know this issue lies with this particular request payload. You can literally copy and paste that payload in here, and within a second you have a reproducible case that you can debug and so on. So I really think it's kind of neat to have this. Just the whole framework makes things so easy to troubleshoot different things that are not even part of your contracts yet. And finally, when you run your contract, there's a target that you can run. It'll generate all these tests for you. You notice in case of this consumer driven test subfolder, it will create one test class that contains all different kinds of all the contracts that you define. And here's an example of what that generated test look like. I think Spring is using AssertJ as their asserting technology. We use the same. I like AssertJ. I think it's great. So to me, this is actually very readable, and I like the way this is generated. So really cool stuff once again. And I'll show you in a bit. You'll notice that up here we are the test that's generated is really saying we're sending this request that it gets from the contract, and then we're expecting this status response, and it's comparing that, and then it's checking against the content type, and then it's doing all these verifications of the payload, making sure that they're exactly the same. Now, like I said, if you don't have any body matchers for the response, you want to have this very bottom line here where it's actually checking for the package ID and making sure it's numeric, right? And why is this important? Well, these body matchers are actually extremely important if you want to create tests that are reusable and that may send back some data that is dynamic in nature. When you're creating a package, you're saying, give me a new package, and you get back an ID, right? And if I were to stick that response back into expected response with that package ID, my test would fail, right? Because the second time invoke that, we would get a different package ID, and it wouldn't work. So the way to handle that is to define what we call dynamic aspects of your response using these body matchers. And we're essentially saying in the contract itself, you notice we say under matchers body, I'll say within the results payload, I'm looking, grab me a package ID. So it's almost like capturing that aspect of the payload, and it's like removing it completely from the equality check of the payload and saying, I'm going to check that myself using this logic here, which is I'm going to use the BiRegX type of match. And there's a number of predefined matchers, and this one's using number, saying just make sure it's integer. So I'm going to now skip to the demo, which being that I kind of covered most of the stuff I was going to show in the demo anyway, so it's going to be fairly short, actually. We're at 11:40. I'm actually going to try to finish this by 11:45 and leave some time for questions as well. Can you see my IDE? Yeah.
Yes.
So here's any questions so far with what I've talked about? Okay. So I have the packages contract test module, which contains the contracts we've seen. And let's look at the consumer-driven folder with the create proxy. This is the one I just talked about. And this is the body matcher. Now notice there's nothing, no build, nothing is generated yet. And let me show you how easy it is to turn this into auto-generated JUnits. Just open your Gradle, go to verification, generate contract tests target, double-click on that, and this should process all of these contract tests, and it will create a build folder under your contract test module. And it's running. It takes like a few seconds usually. This is not even running any tests. But yeah, this just generates, it's done. So under build, you will find your tests right here. And this is a cool way to kind of tweak your contracts to make sure that you're actually matching what you expect. You know, I see this generated code and I go, oh, okay, like, let me show you really quick. If I were to remove, this whole matcher section over here, right? And I run that again. All right, so notice what happens here. Now it's checking for this package ID, and I don't want that, right? Because that's going to fail the test for sure. And this is why, you know, there's going to be payloads like that you just want to match and you want to like almost extract out. And this is a really efficient way to go back and forth between your contract and what your test will look like. And once you have this, you really just, it's part of your CI. It builds as one of your modules in your project, and you see it in your Jenkins test results, as I will show you. Case here. So it'll just come as basically your any JUnit tests. You can see we have consumer tests, 4 of them, and then producer about 11 or so. So how do we measure success with this type of a solution? Well, we're definitely looking into a number of reported issues due to API interoperability, and we're hoping for that to be really close to 0. We've seen improvements. You know, we haven't seen many issues related to API problems. And we can always improve in this area. We can build more contract tests. We're also looking for effort required to write automated API tests to be similar to unit testing. And then we want developer confidence really to go up as we're pushing out new features. And this can be kind of measured, this can be quantified by how many changes and features we're pushing out, and we'd like that to go up as well. And finally, in conclusion, I'll say unit tests can be effective if used properly. mocks for API testing should be used judiciously, as I've shown, and then consumer-driven contracts can be a cost-effective solution to automate API testing. And with that, I'll leave some time for questions. Awesome question. I had the same exact questions myself when I was looking into this for the first time. You know, in an ideal world, like, you want to minimize the amount of logic you need to put in, and if it caters to the properly covering the use case of the endpoint and the request response, that's perfect, right? But as you mentioned, there's going to be cases where you want to do some more massaging of the response coming back. You want to be verifying more things, like, is this element present as a subchild, as a child of this parent element? And turns out that all those things are well supported within the framework of Spring Cloud contracts. I would urge you to, if you're interested to try this out, go to the springcloud.io, Spring Cloud contracts, and they have a library. I've shown you only one, which is the regex one. They have like a lot of different ways you can do matchers. And turns out you can also use Groovy, at which point, I mean, Java, with Java, there's no limits. You can write a method, and then you can invoke that method from within your contract to verify things within the payload. So I think that's kind of useful. A good question. These are the metrics that we identified as probably being like a good way to quantify our success. One area of improvement still is to actually enforce these and actually start tracking them more effectively. We have some informal ways of tracking these currently. For example, number of times a team A or B has reached out to us with an issue in production. We haven't seen those for quite some time, right? Which is great. Of course, that's not like super scientific way of quantifying this, but I'd like to say that this gives us like the tools we can utilize to give us a better idea of how effective this really is. So we do have some more rigorous counts of issues and bugs that are tracked by DevOps, and we're yet to actually go and correlate this, our introduction of Spring Cloud contracts, to how those numbers have been affected. But that would be kind of an interesting exercise we should probably do. Thanks for the question. Really good. So you can do type checking with the Spring Cloud contract as well, right? I shown you one regex by it says make sure it's a number, right? In a way, you're saying this ensure that the payload coming back contains package ID that is numeric. And I also said there's many different ways to do kind of verifications that may vary in terms of business logic checking and also just simple semantics and type checking. But typically, these contracts are really not meant to test, like no implementation should be ever covered here. And we're really more interested in just the structure of the payload and maybe presence and very loose type, high-level types of the fields that we're getting back, right? Ideally, you shouldn't get too detailed about, coding verifications for these responses. Well, good question, and that goes back to the TDD approach. And you can do TDD with unit tests. You can do it with contracts as well. You always start with the requirement spec. You always talk to your product manager, talk to the end users, do the research, find out what the gap is, build the most valuable features, prioritize, translate those into your tests, right? And if something fails, it's not that, it shouldn't be generic type of failure. I mean, we have transient issues all the time. When you deploy a code that's well covered and has a contract and it fails, and the reason is, well, service A is currently down, that is okay, because those transient issues are to be anticipated. There are different ways to handle those using different scalability, high availability solutions that we can put in place. But these contract tests are not for that. They are mainly suited for ensuring that the behavior we defined and the use cases are, tested and checked. So it's driven from the requirements spec, I would say. So does that kind of answer the question? Or maybe I was not.
No, it's fine.
Thanks. Well, if there's no more questions, I'd like to say it's been quite an honor. Really thank you for allowing me to present this in this forum. I think it's a great start, and thank you, Rita, for starting this great town hall. I look forward to doing more topics, and I hope that it can only get better from here. Okay.